binary conversion, and we talked about that. I didn't give y'all a homework assignment on it, I don't believe. Hopefully you remember. If not, cover it again. But we're not going to cover it real hard. For one thing, there's only like a couple questions that have most on it. Alright, so if you have this number, and you want to convert it to binary, it's already in binary. If you want to figure out what its decimal equivalent is, yeah, just remember that this is the ones place, right there. This is the twos place, that's the fours place, that's the eights place, and I'm not going to write the rest of them right, but you know how it works. You know, that's the 16s place. I guess I will write the rest of them, but I have to space them out. That's the 32nd place, that's the 64th place, and that's the 128th place. Right? We remember that? We did that? Somebody tell me we did this.
We did it.
All right. Okay. So anyways, so if you have this digit, if I say convert 01010101 to decimal, show your work. All you do is go, okay, well, that's a 1, so 1, and I always start from left to right because I can double in my head. 1 plus, are there any 2s?
No.
Are there any 4s?
Yes.
Are there any 8s?
Nope.
16, yes there is. There's no 32s. What's the next number? We do have a 64, and we don't have any 128, so that's it. And yeah, if you add them up, great. But if I say show your work, that's really all I want to see. I don't care if you can add. I care if you understand the concept. You can always whip out a calculator and add. It's really enough about that. 8 bits in a byte. Remember that. I don't think I'm going to ask anything on ASCII, so we just leave that alone. I ought to make us go back and do the minimum and the IO manipulator. Even if I reduce the number of questions about it on the exam or just flat out give them to you. I gave them short shrift, so we're going to talk about them now. I need to go back to chapter 3, which is where they were mentioned. So, say you were going to print some data, and you wanted it to line up all nice and neat. Well, we got some problems with how we know how to do this. And we did this. For, x is equal to 0, x is less than 10, x plus plus, and we printed out, C out x plus, and then we printed out POW x to the power of 3, and then we print it out, POW x to the power of 5, followed by EMDL, whatever. I can't do these in my head, so I'm just going to change them to 2 and 3. Pretend that there are spaces between them, even though I didn't put the spaces. That's going to print out 0, followed by 0, followed by 0, right? Because 0 and 0 squared and 0 cubed is that. And it's going to print out 1 and 1 and 1. And it's going to print out 2, and 2 squared is 4, and 2 cubed is 8. All right, and then what if we do 3? 3 squared is 9. And then, 9 squared, or 27. And then what's 4? Maybe we're going to actually write this code in. That's 16, and then 4 times 16, I believe, is, what is 4 cubed? Is that right? 64. All right, and then 5, 125, right. They're not. They're starting to break right. They're not all nicely lined up. We could fix that by putting tabs between them. Now, tabs is the clumsy way of doing that, but we could stick tabs between them. You know, and then they'd be spaced out. You know, and they might look kind of nice. What if those are too far apart? Or what if the value is too wide to fit in a tab? And what do I mean by that? What if we were printing first names and last names with tabs between them? Joe, Bob, okay, that's great. You know, Sam, Jackson. You know, but then you wind up with somebody with a really long name, Frederica, right? And then you hit tab, and then what is Frederica's last name? You know, whatever, Thompson. She's my relative. There we go, right? It's not lined up. It's no good. So using tabs isn't a really good way of formatting your data either. We would like to be able to change this so that every item, we could specify a certain number of columns for it. Or every item here, we could specify a certain number of columns. What if we decide that no first name is not going to be more than whatever this is? Let's figure that out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That nothing is ever going to be more than 11 characters wide. Well, we would want to set something that would say, okay, this first piece of data needs to occupy 11 and a minimum of 11 characters. And so this one would get padded out to be 11 long, right? Well, let's pad it out. Right now it's 3, 4, 5, 6, 7, 8, 9, 10, 11. How about Sam? We'll pad Sam out to 11. 1, 2, 3, 4, 5, 6, 7, 8. Oh, wait, that was already 3. That's 11 as well. And that's 11 as well, okay? But we don't want to have to figure out that spacing. We don't want, you know, C out to have to, you know, we don't want to put in varying amounts. We just want to say this column is 11 wide and this one is whatever we decide, right? Or if we're printing these out, we want them to look like this. If this one's going to go all the way up to, you know, all the way up to an equal 10, if I made that an equal sign so that it would count up to 10, well, then how wide does this first column need to be, including that final space?
3.
Needs to be 3. So we would want each one of these to be padded out to 3. How about the second one? How wide does it have to be, including the space? We would want them all tabbed out to 4. There's the last one. We don't really have to specify a minimum. We could, but we don't really have to. And what if we want the columns to line up a little bit different? What if we want to make each one of them 4? That's cool. We can do that. There's you know, we would just set the minimum width to 4 rather than 3. What if we wanted them, right now they're left justified. But honestly, after we set the command that I'm thinking of, they would come out like this. They would be right justified. And if we wanted them left justified, we would have to modify something. We could make them either left justified or right justified as we were printing them out. And so those are called I/O manipulators. If you've taken a Java class or a Python class, then you're used to seeing things like this, a %4s or %11s. I'm going to print out the string and I want it to occupy 11 characters, right? Or I'm going to print out an integer and I want it to occupy 4 spaces, right? And so you might use %4d to mean that I'm printing out an integer and I want it padded out to 4. Well, the I/O, the stream insertion operators, the greater, greater, and the less than, do not support this kind of stuff. So delete that from your mind, and we're going to learn about the I/O manipulators. I/O manipulators format the output of the that. Okay. To use them requires the I/O manip header file. So you use, # include I/O manip in order to use them. of course, we'll be doing all this in code pretty soon. So you can specify the size, the minimum size it's supposed to occupy, the position, meaning whether it's left justified or right justified, the number of digits. Well, what does that mean? Like decimal places, right? Sometimes you want to specify the decimal places, right? If you're printing out somebody's weight and you want to, you don't want some person's weight to be 100 like that, and then you know 100.5 and then 180.12, whatever. You might want them all to be printed out to the same number of decimal places. So you use min to specify the width of the item, or the width of the output. It gets padded out. And then there's a precision that specifies the number of decimal places, or the number of digits total. So set precision specifies the number of digits. Now, sadly, in my point of view, set precision behaves two different ways depending upon another I/O manipulator. There's one called fixed, which makes it specify the number of decimal places. And then if you don't call fixed, it means it specifies the total number of digits of accuracy. And so if you do set precision 2, but you also set it to fixed, then your output's going to look like that. But if you do set precision 2 and you haven't specified fixed, then instead it's just going to display 2 digits of accuracy. Stupid. So I would always use the fixed operator before I use the set precision operator. Doesn't make sense yet. We'll see it in action, and it will. All right, so stream manipulators are used to control how the output field is displayed. Some of them affect just the next value displayed, set W. And I called it min, and I'm going to delete that and replace it with the actual keyword, which is set W, which means print this in a field at least X spaces wide. It will pad it out with spaces. By the way, it doesn't truncate. So set W specifies the width of the output. Now, if you try to print something, like if you set the width to 2, but then you print something that's 10, it's not going to squeeze it into 2, and it's not going to truncate. This is a minimum width. If you try to print something that's larger than the width that you specify here, well, all bets are off. It just pushes everything over. You can't do anything. So you better make sure that set W has the actual, largest value that you need. If you goof that up, then it's a certain point. If you print a certain value that's larger than that width, well, then all the, it's going to be ragged columns. And then there's fixed, which means use decimal notation for floating point values, like 1.23. Set precision. When used with fixed, it specifies the number of digits after the decimal point. If you don't use fixed, it prints it out using the many significant digits. And if you've taken a physics or chemistry class recently, you remember what significant digits are. Show point always prints decimal for floating point values. Well, if you call fixed and you set a precision, then you don't need to call show point. It will always print the decimal point anyways. So let's do that little bit of code that I was showing you where we were printing out a table. Let's crank up Visual Studio. Make a new project. Add our boilerplate, all the usual stuff. But I'm going to add an extra include to the top because we're doing an I/O manipulator stuff. So I'm going to have to add I/O manip to the top of my code. Project. I'm going to call this K because this is Lecture K. Source file. Add a new item. I'm also going to call this K. Fun. K.cpp. Call yours whatever you like. All right. There's my boilerplate. To use the I/O manipulators, I have to add one more header file. So I'm going to do # include I/O manip. I'm going to to go back to my notes and add something, which is set W has to be called every time before, it has to be called before each value to be formatted. You can't just call it once. Do it before every piece of data to print. On the other hand, set precision. You call it once, and it stays at that precision until you call it again. And while it's annoying to have to call set width before each piece of data you print, it kind of makes sense, right? The width of these things is going to change so often that you wouldn't want to just call it once and then have everything else follow it. Well, I might. But on the other hand, set precision, it'd be really annoying if you had to call that before every single number. So just set it once, and then if you ever need to change the format, then you can call it again. So let's write a little loop that'll print out that table I was talking about. We could even make it an awesome little nested loop, but meh, not right now. So for int x is equal to 0, why don't we start it at 1? 0 times 0 times 0 is boring. And then x is less than or equal to 10, maybe even go up to 20. And then x, or what's one? Yeah, whatever, 10. And then each time we're going to increment x by 1. And so let's see out x, followed by a space. And then let's see out, oh, and by the way, if we're going to use a POW function, you better include CMath if you're not using Windows. So you ought to put it anyways, even if you are a Windows user. So see out POW x to the power of 2. Followed by a space, and then see out POW x to the power of 3, followed by an ENDL. And there's my stuff. Right, it's not lined up nice at all. So we're going to use set W to make them line up. And I think we decided that the first one could be 3 wide and the next one could be 4 wide, and we didn't care about the last one. So before I print out x, I'm going to print out set W3. So do you see what I just inserted? I just inserted that. You have to use the double arrows. You can't just put set W3 immediately followed by x. It's set W3 and then 2 more arrows and then x. Same deal here. Set W4 followed by 2 arrows. And while we're at it, why not set W5 in case we ever added another column, right? Now when we print them, they'll be all nice and pretty, like that. But what if we want them left justified? Right justified looks pretty good. I kind of like it like that. But we'll find out how to left justify it in a minute. All right, let's do some other little funky kind of table. And this one is going to be a nested table. It is going to be nested loops. Because I want to calculate some kind of multiplication table, except it's actually going to be division. So Same kind of thing. For int x is equal to 1, x is less than or equal to 10, x plus plus. And then inside it, for y is equal to 1, y is less than or equal to 10, y plus plus. And then inside it, we're going to see out arrow, arrow, x divided by y. I better change those ints to doubles. And by the way, it's underlining y because I forgot to give it a type at all. I'm going to put this inside parentheses just because I like doing that if I'm printing out the result of some math. Followed by a space. Now honestly, if I was going to use set w's and things like that, I wouldn't even need to follow these things with spaces. But that's normally what we would do. Okay, change that int to a double. Why? Because I want to see things like 0.5 and 0.333 and stuff like that. We could just use casting to take care of that. But I feel like doing it this way. Make that one a double too. And after we print an entire row of digits in the inner loop, we want to print out an end line. ENDL. All right, this table's not going to look very good when we print it out. And it honestly wouldn't even look that much better if we use set W to make it, try to make it look prettier. That's kind of bleh, right? Well, let's try set W to make it look a little bit better. I think the maximum that I see is 1, 2, 3, 4, 5, 6, 7, 8. So let's do set W 8. And I think I'm going to wind up lowering the numbers, right, because it's going to go off the edge of the screen. But your screen is, your font's smaller, so it might be okay. So right here, before my x divided by y, I'm going to do set W, parentheses 8, and an arrow, arrow, like that. That's going to go some way towards making it look nice. But not that great. And like I said, I'm going to lower it so that it's not just, you know, maybe I'm going to print out like to 5 rather than 10. So I'm going to change these 10s to 5s, just so I get it all on one screen. Looks nicer. Okay, this is my little table. I still don't like the way it looks. I don't like the fact that this is 0.333 and 666, and all of a sudden this one doesn't have a decimal point, right? Maybe I want them all to have decimal points. Maybe I want them all to have 1, 2, 3, 4, 5, 6 places. I can do that. What I would do is before I started printing anything, see out, arrow, arrow, fixed, arrow, arrow, set precision, and I want 6 places after the decimal point. Now it'll look a lot prettier. I'm liking that a lot better. So things to note. Set W has to be called before every piece of data you print that you want formatted. As soon as it prints one piece of data, just a sec. As soon as you print one piece of data, it forgets set W setting. But fixed and set precision are kind of like fire and forget. Once you set them, they stay that way until you reset them to something else. Yes, sir?
What's the include for that one?
IOManip. I really need to learn to repeat the question for the viewer. So the question was, what was our include? It was IOManip.
You scroll down.
Uh-huh. That is almost all there is to say about IO manipulators, except for the one that right justifies versus left justifies. Now, I don't know why I don't like covering this subject at the exact point at which they want me to. I think it's because it seems spurious. We're learning about math, we're learning about this, and we're learning about that, and all of a sudden, oh, by the way, we're bringing in a new header file, which we won't use again for several chapters, whatever. I like to introduce the concepts and then get to loops before we talk about it, because really the only time you want to call set W and precision and stuff like that is if you have some kind of looping output. Maybe that's not the only time, but anyways, I disagree with the way the book is structured just on that one. So here we go. You could send one called left, which would left justify it. You could send one called right, which would right justify it. Set W, we've seen. Set precision, we've seen. Show point causes a decimal and a trailing zero to be displayed, even if there's no fractional point. Or could we just have used show point rather than the fixed and the precision? This is kind of a question for myself. So I'm going to comment that out, and I'm going to instead see out show point and see if it did the same thing. Sorta, but not really. What's the difference? Honestly, I don't know why it's doing what it's doing. Why did it display 1, 2, 3, 6 decimal places here and only 5 here? I think I get what it's doing. It's playing it's putting 6 digits up. Nope, I can't figure it out. So anyways, show point kind of did what we wanted, but not really. You could do it if you wanted to, but I would just use fixed and set precision. I'm going to even delete that. But we didn't use right and left yet. So when we ran this one, and our data was left justified, that's great, but what if we really wanted it right justified? And honestly, I don't remember if that's one of the ones that you have to call every single time, or just once. So let's find out. So I'm going to do cout, excuse me, we wanted them left justified, they were right justified by default. Cout left, and then let's see if that does them all that way or not. It did, okay. So that's another one where it's fire and forget. Once you set it, it sticks until you change it. Which kind of brings me wondering, is there a way just to reset them all back to the default settings? I guess if you're picky enough to start using them to begin with, and you're picky enough to keep, control of them the whole way. So that's a left justify. And this is a right justify. Would you do both, one after the other? No, of course not. All right, and that's it. Oh, I don't remember doing this one. But it's not a big deal for those of us in this class because everybody is using a compiler written after the year 2011. No wait, that's not it. Well, I'll just mention it. If you have a string and you're trying to pass it to a function which takes what are known as character arrays, C versions after 2011 will do that conversion for you automatically. C versions written before 2011 will not. And so you have to wind up doing something like this. C.C_str. Now, this is dumb because cout will accept strings, right? But say it was a function that didn't accept a string and we had to convert it to a character array. You follow it with .C_str. That converts it to a character array. Why do you care? Well, like I said, there will be some functions which demand character arrays rather than strings, and you may be using an old compiler, and if you're using an old compiler, that's how you do it. Now, I've only had one student get surprised by that. She came up and she had installed a different compiler other than Visual Studio, on her laptop. Her laptop was a small laptop. She wanted a lighter development environment than Visual Studio. I totally understood that, but it happened to not support automatic conversion of strings to character arrays. So what is a character array?
What about Visual Studio 2010?
I don't know whether it does it or not, honestly. I think it's one of those things that they started doing, but that it wasn't a part of the standard until a certain point, where it was mandated. And so it would not surprise me if Visual Studio had support for it. So what is a character array? It's something that we haven't really seen. Well, for one thing, it's because we haven't talked about arrays, as far as I recall. But it looks like this. We say char, like first name, and then we specify a width. And then we say, okay, that's my first name. What this does is it tells the compiler to allocate space for 20 characters in a row. And, oh, by the way, initialize it with BOB. Well, that's kind of silly. We told it to be 20 characters, and we only filled it up with 3. What are the rest filled up with? Zeros. Nulls are what they're called. That's how C and C++ know that the end of the string has been reached, is when it's processing it character by character. Once it hits a 0, it knows it's done. It knows it's done. So, go ahead and type that in there, and we can call it fname to shorten our, we can even call it fn just to shorten our amount of time. And we're going to write a loop that prints out all 20 of those characters. But we're going to print them cast to int, so that we can see the ASCII values of them instead. So, for int I is equal to 0, I is less than 20, I plus plus. Let's see out I, followed by a space, followed by the integer value, int of fn square brace I. If you've taken another programming language, Python, Java, whatever, I did something wrong there. That we needed an end parentheses there after the fn subscript I. And if I wanted to do new, the style of casting that I really like, I would put the parentheses around int and remove them from the other thing. Sorry for making the changes. I took all the parentheses out of there and I just put them around the int instead. Okay, so that converts the character at that position to an integer so that we can see its ASCII value. If you've done list programming, like in Python, or if you've done array programming in Java before, you're used to the idea that that's the first position, that's index value 0. That's index value 1. That's index value 2. So when you're specifying, when you're counting out positions in a list or an array, something like that, they always start at 0. In the vast majority of languages, rather than 1, they're known as zero-based indexing. That's why we had a quiz 0 and a homework 0, just to kind of trigger that in your head. All right, let's do it. And run it and see what it prints. All righty, so that's the name, B-O-B, although the second time we did it, I used a capital B. So the first character at index 0 is a 66. The second character is a 111. The third character is a 98. And if I look them up, that's a capital B, that's a lowercase o, and that's a lowercase b. I'm not going to hit ASCIItable.com to prove it, just accept it. And the rest of them are zeros. It knows that it's done when it hits the first 0. We could stop printing it at that point. We could be looking for the 0, and as soon as we find any of them, just stop. Make our loop end at that point. And there's different ways of doing that. I'm happy enough with that as it is, though. We could modify our condition, and fn subscript I not equal to 0, right? Something like that. There's some kind of if logic we could use that would get that going. Character arrays. Character arrays are extremely important if you're doing C programming rather than C++. C++ comes with the string class. The string class makes everything so much easier. You don't have to create arrays like that. The string class just lets you do this, and then it comes with a whole bunch of functions that let you manipulate the data. Like if I type s dot, I get all of these methods that are part of the string class. Incredible amounts of stuff. I don't get anything like that with a character array. Yeah, there might be some library functions which will do the same thing, but certainly not as easily as a string class. That's why classes were invented. C++ has classes, C does not. So C does not have a string class, so you wind up using character arrays a lot. One of the things about character arrays is that you have to declare them to a large size, the size of the largest item, right? Really, this only needed to be 4 wide. I could have put a 4 here rather than a 20. Why 4, not 3? Because you have to have room for that final space. Excuse me, that final null, right? So that's position 0, that's position 1, that's position 2, that's 3 already, but there has to be room for that final invisible null. So that's why I can make it 4. But then what if I wanted to put, Jeff in there later? Well, too bad, I couldn't, because run out of space. So if I did string copy fn comma and then I typed in something else like that, I wanted to put Jeff in it, that's not going to work because it's too long to fit in there. It looks like it'd fit, but remember the trailing null. So it takes 4 plus 1 for the trailing null. It would have to be at least 5. And that's annoying. It's annoying to have to keep track of the largest piece of data that you need to know and to allocate that in advance because it's kind of wasted space in a way. What's worse is that once you declare an array size like that, if somebody feeds it more data than will fit, then bad things happen. You wind up with data corruption. And that is a common attack vector for breaking software, hacking software, is to give programs input that's longer than the arrays that are allocated to hold that. Now nowadays it's not quite as common as it used to be because not as much software is written in pure C anymore as used to be. The string class grows and shrinks according to the amount of data, so you don't have to set a width like that. Anyways, now that I've copied Jeff in there, whoopsie, what's my error? Doesn't really matter, we're not learning C programming at this point. Oh, here it is. This function or variable may be unsafe. Use string copy underscore s. Microsoft is doing this, and if you did it on the Mac, I'm not sure you would get the same warning. This is probably a Microsoft specific thing. What Microsoft is telling me is that this is an inherently unsafe operation. Copying this into this is unsafe because the compiler doesn't know whether we've declared fn to be 1 or 1,000, right? And if it's 1, then this is definitely going to fail, and there's going to be data corruption. And if it's 1,000, it'll work fine. So there's a variation of string copy that lets you specify how many characters that you want to copy in, or the maximum size of your data to be more precise, how long this array is. So Microsoft isn't even letting me compile it with this unsafe code here. But I could do #define, CRT secure no warning, something like that, in order to convince Microsoft that I really want my code to be able to do that. And why would you do that? Because you'll find online and in businesses code that was written before the invention of these safe versions of these functions, right? And you have to maintain backwards compatibility. So I'm going to get rid of that, just because I like my code to compile. All right, now we're ready to hit chapter 5. But I do want to do one thing. Oh, that's my Java lecture. See these 2 comments here? Set WS to be called before each value to be formatted. You can't just call it once. Do it before every piece of data to print. Meanwhile, set precision, you call it just once and it stays at that precision until you call it again. I'm going to leave those in the exam, and I'm going to make them part of a notice to make them incredibly easy to remember. And as a matter of fact, if you get them wrong on the exam, I'm probably even going to give you credit for it because I'm throwing something at you, you know, the last day before the exam, and that's really against my principles. But I should have covered it before we got here. I don't want to take it out of the exam, so I'm going to leave it here. Notes for the exam. And use set W to specify the number of spaces the data should occupy. And then use set precision to specify the number of digits after the decimal point. Make sense, guys? If you don't remember that these are notes that are actually, you know, right there. If you hit a question about set W and set precision and, you know, whatever, raise your hand and I'll come help you. And like I said, even if you get it wrong, I'll probably give you credit for it. But then it'll come back again on the next exam, and it won't be so free and easy. So let's go look at the next chapter. We need chapter 5. But not too long. I managed to talk 40 minutes about that stuff. But it was good stuff, in my opinion. Haven't seen anybody fall asleep yet, so I'm considering this a success.
I can fix that.
You can fix that, thanks. All right, loops and files. Seems like we've already been using loops. Have we not? We've been using while loops at the very least. Correct me if I'm wrong.
Yeah. We just got over it.
Yeah. That's like one, when you're learning programming, you have to learn everything at once, and so we have covered loops even though we hadn't hit the chapter on loops. Alrighty. So right out the bat, it tells us plus plus is the increment operator. It adds one to a variable. We already know that, but we're seeing it again. Value plus plus is the same thing as value equals value plus 1. You can use it either prefix or postfix. If it's prefix, it means it's the first thing that happens when the expression starts to be evaluated. Very first thing. It's very high on the precedence table, right? Like PEMDAS, it's way before any of that stuff. But if it follows the variable, it's the last thing that happens in the expression. And it actually can make a material difference in the values. Like if I do this, A is equal to 10, B is equal to A plus plus, but then I do A is equal to 10, B is equal to plus plus A. They look like similar pieces of code, but B winds up being different values. Plus plus means do it after the expression is evaluated. So A is equal to 10, okay. Copy A into B and then add 1 to A. So at this point, B is equal to 10 and A is equal to what? It had 1 added to it. But what about this? Plus plus in front of the variable means do that before you do anything else. So A immediately gets incremented to 11 and then it's copied into B. So B is equal to 11, A is equal to 11. And by the way, not that it matters most of the time, but if you're trying to write the absolute fastest code possible, you use plus plus in front of the variable rather than after, if it makes sense to do so. Because this only does like one memory reference in order to figure that out, and this does 2 memory lookups in order to figure that out, and the fewer times you hit memory, the better. On the other hand, nowadays machines, you know, run in the gigahertz, right? So it's really not nearly as important anymore. And I bet that the compilers that optimize code, of which every person in here is using a compiler that optimizes the code, probably fixes that anyways. But that's why if you're looking at old code, you'll see, you know, some kind of loop like that. While A is less than 10, do something and then add 1 to A. That would be marginally faster, a couple nanoseconds faster than if they typed A++ on that platform with that compiler. Either way, it winds up adding 1 to the value of A. And if you're concerned about somebody not understanding whether B is going to wind up with being 10 or 11, just separate them, right? A is equal to 10, B is equal to A plus plus. You absolutely know what the values are going to be. What is B going to equal after those 3 lines execute?
10,
Right, and A is going to wind up being
11.
11, right? So, you know, by writing it in 3 lines rather than 2, we've made it absolutely crystal clear. Or A is equal to 10, plus A, or either way, right? It doesn't matter at that point because it's all on one statement by its own. But, you know, even if we want to make it look identical, you know, and then B is equal to A, what is A going to wind up being? It's still going to wind up being 11, but what's B going to equal? 11, right. So, by trying not to get all cutesy and put multiple things in one line, you can make your code clearer, and it reduces the ambiguity in the mind of the viewer. The computer doesn't care whether we write simple or complex. It matters to us, though, when we're trying to validate mentally whether the code is good code or not. And even this is short code, but you could write long code. You could do something horrible like this. While, and it's not that horrible, while x plus plus is less than plus plus c, right? That's horrible. Your brain kind of breaks trying to figure out what it's doing. Instead, you know, write it in some way where you're not changing it as you're comparing it. You'll see that C programmers are very fond of doing it, you know, the way that I'm just showing here, because they're used to dealing. C is a low-level language, so to speak. You're controlling the bytes very specifically. C++ is a superset of C, so you can do all that. But anyways, people who grew up programming C tend to do things like combine the plus plus operators in the middle of their expressions more than other people. In my experience, could be wrong. All right, so plus plus and minus minus can be used in complex statements and expressions. This is all just telling you exactly what I told you. So, can be used in expressions. Result is equal to num1 plus 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 minus minus num2. Again, I consider that incredibly tacky. Computer would run it just fine. Now, it doesn't mean just plus 1. If you do this and then put plus plus after it, well, the thing in front of it has to be a variable, right? So if you add num1 plus num2 and it gets 10, and then it's trying to do 10 plus plus, well, it can't magically fundamentally change the value of 10 forevermore to 11. So the thing in front of plus plus or after plus plus do have to be variables. But you can use them in relational expressions. While plus plus num is greater than limit, or if num plus plus is less than whatever. So introduction to loops, while loops. A loop is a control structure that causes a statement or multiple statements to repeat. While expression do something. Something could be one line of code, or it could be a block. If it's one line of code, you can still enclose it in the block. You just don't have to. So the expression is evaluated. It's kind of like an if statement. If this is true, it goes ahead and does it. If this is not true, then it doesn't do it. But if this is true, not only does it do it, but after it does it, it comes back up here and reevaluates it. And if that is still true, it executes the body again, over and over and over, until this expression is no longer true. That kind of implies that statement had better be something that changes the expression. Otherwise, it'll always be true. It'll do an infinite loop, unless there's some other way out, like a break statement or a return statement. So it is like that. Expression, true, do some statements, and then come back up here. So this is your block of code or your single statement. Just keep repeating while the expression is true. Okay, now this is kind of dumb because it doesn't initialize number, probably because it does in this line of code. So int number is equal to 1 while number is less than or equal to 5. It starts off at 1, it prints hello, it adds 1 to 1 to number. So now number is 2, it's still less than or equal to 5, it prints it out again. So number is going to count from 1 all the way up to and including 5, printing out hello each time, so it's going to print out 5 hellos. If we just made it less than 5, it wouldn't print out 5 hellos. It'd print out 4. Like if we did this, x is equal to 1 while x is less than 5. See out x. And no, I didn't format all this right. Like that. Well, it's going to do 1, 2, 3, 4, but once it hits 5, is 5 less than 5? No, it's not. So it's only going to print 1, 2, 3, 4. On the other hand, if we change that to less than or equal to, it'll print all the way out to 5. Now to me, that's an easier thing to read. I like less than or equal to's. 1, 2, 3, 4, 5. You'll see some programmers do this. Want to count to 10, do x is less than 11. They don't want to use less than or equals to, they just want to do less than. And there are some valid reasons for thinking that way. But I would just say pick whichever one makes the most sense to you. So I'm going to delete that advice. My brain thinks in terms of less than or equal to, so that's typically how I like to do it, in most cases. I'll give you an example of when it's not true. No, I won't. We're just going to continue. It's what's known as a pretest loop. Pretest meaning that the loop is evaluated before the condition. Right? It can't even get into this code if this expression is false. Well, number is equal to 6. While number is less than 5, well, it's not less than 5, so it's not going to go in there, just like if this was an if statement. But there's a post-test loop as well. So pretest loop, the condition is tested first. Right, so x is equal to 6, while x is less than 5, do something. See out x. Won't print anything. But there's a version of the loop where you put the while at the end rather than the beginning. And you Java people have seen this before. You Python people have not, because it did not have post-test loops. X is equal to 6. Hey, let's do some stuff. Followed by while x is less than 5. So, post-test loop. The condition is checked last. Tested last. So this won't print anything because the condition was false and it's tested before the body of the code. This will print something. X is equal to 6? Okay, great. Print it out. Now keep running while x is less than 5. Is x less than 5? No, it's not. So now it's done. But this would print 6. Because it is not tested until after the body of the loop. So, if you want the body to always be run at least one time, you should use a do loop. If it's okay for the body to not necessarily be run, you can use a while loop. Now, honestly, if you try hard enough, you could write any loop using any structure. And I'm not going to give you examples of that. But you could write do loops in the form of while loops. That's why Python doesn't even have do loops. You could write while loops with the form of do loops. It would look really kind of convoluted and stupid. So there's no reason to do that, but you could. So while loops, pretest, do loops, post-test, And there's another kind of loop, for loops, which are also pretest. So generally your while loops work like this. While, you got to do several steps. You have to initialize, you have a test condition, and then you have an update. And somewhere in there you have the body, like that. What do I mean by that? Okay, you initialize x is equal to 0, and then you have your test while x is less than or equal to 10. And then inside it, you have some kind of body. You're printing x out or something, and then you update it, x plus plus. So that's your update. Excuse me, that's your init. That's your test. Then you have some body, and that's your update. The for loop just lets you mush all those together in one cute syntax. For int x is equal to 0, keep running while x is less than or equal to 10, and after the body executes, increment x. Just a shorter syntax. Right? If we took the braces out, then this is 4 lines of code, and this is 2. Why is it so many fewer? Because the init goes in the same line as the test, as the update. So the general syntax of the for loop is for init, test, update. Of course, it has to be actually valid expressions. Then you can leave off any one of these that you want if you need to do some kind of special case where you're not going to initialize a value. You just leave it off. And I'll give you an example of that. What if somewhere else you CIN into a variable, and then you do this, for, but you don't give a starting value for x. You just keep repeating while x is greater than or equal to 0, and then every time you do something, you print x out. I mean, you remove x from it. And I ought to be making y'all type this, because people get bored if I'm not making you type. But what happens here? If they type in 10, it's going to count 10 down to 0. If they type in 5, it's going to count 5 down to 0. If they type in -1, how many times is it going to print? It's a pretest. So -1 is not greater than or equal to 0, so it won't print anything. And it was okay, according to the syntax, to leave that out. You can also leave that out if you want to. If you're not going to let x be updated up here, we could take that and put that there. Why? I don't know, but you could. You could even leave that out. And this is veering off into the moronic. But you could do that. So if x is greater than or equal to 0, or not greater than or equal to 0, break, something like that, something to get you out of the loop, down, like I said, that's kind of moronic.
That's what I'm all about.
Yeah. So these things are optional as long as you have the semicolons to space them out. Normally you're not going to do that. Watch out for infinite loops. If the condition never turns false, the loop never has a way of stopping. Now you can code it in such a way that it looks like an infinite loop, but there's a return statement in the middle of it or a break statement in the middle of it, and it's not really an infinite loop. Like, I'll make y'all type this. So int v is equal to 10, while, parentheses, v is greater than or equal to 0. That doesn't look like an infinite loop. While v is greater than v, again, that's moronic. It's an infinite loop. Say it's a programming error. C out v. But say we put in some special check. I don't know what, but let's make a variable called repeats. Let's initialize it to 0, but each time the while loop iterates, we add 1 to repeats. And if repeats ever exceeds 100, then we're going to break, or we're going to return out of the function. Now this isn't gonna be too cool because if we return, we're gonna skip our, our pause down at the bottom. So the Mac users won't care, but the PC users are gonna see it close the window immediately. But this is just an example. This is poorly written. Oh, it's doubly poorly written. It would never go into the loop to begin with.
Yeah, that's false, isn't it?
Yeah, like that. While V is equal to V, well, V is always equal to V. So it would be an infinite loop, but we have some check in here to make sure it doesn't run too long. You really do it that often? I have written code that had checks like that inside the loops. Why? Because you don't want your program just to get to the point where it's sitting there not letting you do anything with it. And all of y'all have had programs do that, right? They apparently lock up and you can't close them and you can't do this and you can't do that. And it's because there's some tight little loop that's not giving any processor time to the rest of the application. So if that ever happens and you can identify which loop is doing that and there's no other way to fix it, then you can hack something together like this. More commonly, if I'm going to do something that has a quasi-infinite loop, it's just because I did this. While true, C out, give me number, or -1 to quit. And then let's read a number in. Int num, cin into num. And then if num is equal to -1, then break. Like that. Looks like an infinite loop, but there is a way out. Or it could be a return statement, which would just kick you out of the function. But if you kick yourself out of the main method, it terminates the program. If we're inside another function, it'd be okay. I'm going to run this and see what we've got cooking so far. Nothing. Error list.
Must return something.
I never. Oh, yeah. I'm going to take out that return, though. I'm going to change it to a break. Not Barack. Break. Alright, so it did something. It looked like an infinite loop, but it eventually decided to break out of it because of that little failsafe. Now give me a number, -1 to quit. Alright. Eventually I type in -1 and it bails out and does the rest of the code. It's time to stop. Again, I bet a lot of this was rehashed. But hopefully it's rehashed with stuff added to it. Because I like to introduce something before you actually see it in the PowerPoint, so that the time you see it in the PowerPoint, it's almost old hat. You have two chances of understanding it.